Hello guys, welcome back to my YouTube channel. Today we are going to understand another topic, that is data transfer. So this question can be asked in your exam. It is a important question. So let's discuss which are the following different ways to transfer data to and from peripheral devices. Explain any one in them in detail. Data transfer to and from spherical devices may be handled in one of three modes: program input output, interrupt initiated input output, direct memory access. In this three methods are given in exam. Anyone can also be asked with specified name given. So we need to prepare all three methods. So first we will discuss programmed input output. In that you need to draw the diagram like this, and this is very much easy. From diagram only you can write the description part, but you need to remember the diagram very much properly. In that there is one CPU interface and input output device. So in the interface there will be one data register and there will be status register, false or true. So data register is for handling the data input and output for, and status register indicates the data is delivered or not. If delivered, then there will be true. If not delivered, then there will be false. When the input output device sends the data with IO bus, so it goes to the data register. After that, data bus transfers it to CPU. Input output device sends data is valid, sends to status register. After that, if it is valid, then that will be forwarded to data bus. And where to forward, that we need to know. That will be given by the address bus. After that, input and output read or write, and whenever read or write comes, it will be counted in the status register. And if it is true that it is read, then we will send the message to the input output device that data is expected. It means what? Data is received properly, so it's sending the it also called as an acknowledgement. We are sending that message is received. After that, we said send message through acknowledgement. In programmed input output method, the input output device does not have any direct access to memory. Data transfer from input output through an interface into the CPU. The interface expects the byte into its data register and enables the data expected line. The interface sets a bit in status register that we will refer to as flag or flag bit. When a bit of the data is available, the input output device places it on the IO bus and activates the data valid line. The interface receives the byte of the data from the bus and store it in its data register. It then activates the data expected line. The interface also sends a flag bit in its status register to indicate that data has been received. The input output device can now deactivate the data valid line, but it do not transfer another byte until interface deactivates the data expected line. A program running on the CPU periodically checks the status register to determine if a byte data has been received by the interface. The program reads status register into CPU, examines the value of the flag bit to see if data is available. If the data is set indicating that data has been received, the program can retrieve data from the data register. Once the flag has cleared, the interface deactivates the data expected line, allowing input output device to transfer the next bit of the data. The interface of the each byte requires three instructions: read the status register, check the status of the flag bit, and branch to step 1 if set or set to 3 if it is set. Read the data register. So these points are written from the flow diagram that I will tell you like this way. If from that description you can write description from this diagram. In that, read the data register, then check the flag bit. Flag bit if equals to 1, then read the status register. After the transfer data to the memory, after that operation complete, then say yes, then program will become continue with program. Otherwise, if no, then directly go to the data register. And if flag byte 0, then we need to fetch the data. So that's for today's video. So today's video, I will make another video for another methods in next lecture. So that's for today's video. We will meet in next video. Thank you for watching. Keep believing in yourself.